I am audible, Gopal sir? Okay. Now we can start. Okay. A very warm good evening and heartily welcome to all. We are honored to have the eminent speaker today and eminent resource persons, Mr. Suman Das. And we are extremely happy to welcome our Honorable Principal Madam, Dean Sir, Registrar Sir, and
Arup sir, you are muted. Please
no. Yes. Okay, I'm continuing. Okay. A very warm good evening and heartily welcome to all. We are honored to have the eminent speakers or today's resource persons, Mr. Suman Das. We are extremely happy to welcome our Honorable Principal Madam, Dean Sir, Registrar Sir, and HOD Sir, and all other dignitaries, and my colleagues, and all participants and my students. On the behalf of Regent Education Research Foundation's group of institutions and Department of Computer Science Engineering, I welcome to all for today's webinars, OOP Design Patterns. First of all, we cordially invite our Honorable Principal Madam to come over the virtual dais and deliver some valuable speech for today's webinar. Please, Madam.
Thank you, sir. Am I audible?
Yes, ma'am. Yes, ma'am.
Okay. Very good evening to you all. Actually, we are passing through a crisis time. All of us know that. And during this scenario, there is a paradigm shift in every respect of our society. That is, in education, we are seeing that we are following the online education mode. We are sharing the virtual platforms, Zoom and Google Meet and all those. And there is also a change in business also. And business. And whatever, there is a software company or not, all the business that depends on software. The nature of that software is changing, and post-COVID, the trend is accelerating. However, that has a big implication in software engineering technology also. Now, in this time, more companies are using software to engage with customers directly. Like insurance companies, they have started to offer apps for self-service claims. Like financial institution, they are building software products for customers to apply for loans online, whatever. Like this, in all other industry, there is change in software application. Specific software is needed in almost every industry in this post-COVID situation, helping their customer in every business and for every function. Okay. In software engineering, design pattern is a general, repeatable solution to a commonly occurring problem. They provide a way to solve issues related to the software development using a proven solution. Software professionals can immediately picture the high-level design in their heads when they have that particular design pattern. So they can connect with the pattern. So in this post-COVID situation, we need more and more software development. So the webinar coming up on OOPS design pattern is very much relevant and appropriate in this crisis time and also post-COVID time. So I must appreciate our CSA team for arranging such an event. In this regard, I cordially welcome Mr. Suman Das as the resource person in our virtual platform to light up the issue properly. I also welcome all the participants in this webinar. I'm confident that this session will be engaging one and help us to get proper insight in this topic. Surely it will be an enriching experience for the audience. We hope to host Mr. Dash at our campus for more of such engaging sessions. After the pandemic gets over, I take the privilege to thank Mr. Dash for joining us and sharing his precious time. Thank you. Over to Arup sir.
Thank you, ma'am. Once again, our honorable principal ma'am has conveyed good messages and say something already. Principal madam delivered good speeches regarding the today's webinar, enlightening us. So now, may I request our honorable dean sir to come over the virtual stage and to convey his valuable speech for today's webinar. Please, sir.
Am I audible, Arup sir?
Yes, sir. Yes, sir.
Good evening, everybody. Respected principal ma'am, resource person, Mr. Suman Dash, all my dear colleagues and dear students. As we are passing through a event which may be once in a lifetime or may not be in lifetime also. So these pandemic situations we are passing through. So it has given us most of the challenges also, as we are suffering lots of things, but it is giving opportunities also. The demand for technology-based solutions and software especially has increased a lot and will be increasing many-fold in very near future. So, dear students, it is a great opportunity to just sense the opportunity and grab it and go ahead in your chosen domain and your passion, follow your passion. The topic which CSE department has chosen is very relevant in this objective. So, dear students, I think it will help a lot of you and try to gather whatever you can have from here and motivate yourself and grab these great opportunities which is not always available. So most of the things Principal Ma'am have told. So it is my pleasure to have the great resource person, Mr. Suman Das, and I would like to thank him for providing us his precious time and enriching our dear students and faculty members. Hopefully in future also, we would like to have your kind presence in our physical campus at Barakpur, sir. So once again, thank you very much for giving us your precious time. Over to you, Arup sir.
Thank you, sir. We have got nice speech from our honorable dean, sir. Thank you once again, sir. Now may I request our honorable registrar, sir, to say something regarding today's webinar. Please, sir. So, may I request our honorable registrar, sir, to come over the virtual dais and say something for today's webinar. Please, sir. So I think due to some network issues, sir, still not join in this webinar now. So now, may I request our honorable HOD, sir, to say something for today's webinar. Please, sir.
Hello, I am audible.
Yes, sir. Yes, sir.
Hello, everyone, and welcome to today's session. Welcome to today's presentation, OOPS Design Pattern and International Webinar. So, respected Mr. Suman Das, dear students, teachers, all members, Principal Ma'am, Dean Sir, a very good evening to all of you. Especially to Mr. Suman Das, thank you for joining in the webinar, who are sure to explain a lot about the OOPS pattern and the better perspective that will guide our students in discovering opportunities for growth in this post-pandemic world. So your active participation is important throughout the session. Also, a recorded version of this webinar will be available. So at present right now, I have everyone on mute to avoid background noises that may divert you from listening to the webinar. Thank you, Mr. Suman Das. Welcome our webinar presentation and international webinar. Thank you so much. Arup, please.
Okay, thank you, sir. So now I may request our honorable registrar, sir, if join to say something for today's seminar. I hope so the registrar, sir, joined after some times. It's a great honor for me to introduce and welcome our eminent speaker, Mr. Suman Das. Mr. Das has lots of experience in the industry and several times worked in the industry, and 4 years experience in the technology. The field is .NET, C#, socket programming, Silverlight, Xamarin Mobile, and SQL Server. Mr. Das also worked the field of MVC4 SQL Server for a couple of years, and also works as a work manufacturing automobile domain, .NET, Angular, and SQL Server. And right now, Mr. Das working as a software developer, Blueprint Software Systems in software developer in R&D Blueprint Software System, Ontario, Canada. So Mr. Das have lots of experience in the industry and several technology in the industry. The person is already work. Today we are privileged to have an opportunity to listen to him in this evening. So on the behalf of RERF Group of Institutions, Department of Computer Science Engineering, I welcome to you, sir. Please, sir, now I'm going to opportunity or welcome you, sir, once again to hand over to our today's resource persons, Mr. Suman Das. Welcome, sir. Thank you, sir, and continues to the sessions. Please, sir.
Thank you. Thank you so much. Am I audible?
Yes, sir.
Okay. First of all, very good evening to all my respected professors, my respected principal, dean, and registrar, sir, and also my friends, the students of final year, I guess, or third year and fourth year. So, yeah, I'm also thankful to all of you for giving me the opportunity to discuss my experience, I would say, rather than kind of learning I'm not going in that way. I would say I would like to share my experience and share my knowledge with you. So, Arup sir, can I get the presentation permission?
Yes. Gopal sir, please help. Sir, you can present.
Please share your screen. So please share your screen and the entire screen or only the applications, and we got the screen.
I think you can see my screen, right?
Sir, your screen is visible. Your screen is visible, sir.
Thank you. So, first of all, why I have chosen this topic. So, I was having a discussion with my friend. Actually, he is a professor in your college, Atun Udash. So, I was discussing with him like which topic to choose on because yeah, I have worked with many technologies. For example, .NET, Angular, C Sharp, and then also I'm working with RPA technologies like robotic process automation, and also I have worked with cross-platform mobile application development and all. So yeah, there are various topics that can be, I mean, chosen for this platform. But yeah, I was discussing like this could be a very good start point for the fresher in the industry because being a student and just emerging into the I would say industry, it's a quite different experience in terms of the coding practice, the thing how you are going to interpret with your colleagues and all. It's a quite different thing. So this design pattern and principles are the, I would say, the basic foundation in your very start or in your industry career. So first difference is what I would say. For example, when you are a student and you are given an assignment to write a program, for example, very simple, you are going to write a program, for example, to sort a list or a kind of a Fibonacci series if you are familiar with. So in that case, you are writing your own code and you are submitting that code to your examiner or something like that. But when you are in industry, you are going to collaborate with your colleagues. You are not only the single person to write your own code, but you have to collaborate with your colleagues. And moreover, in a company, you are not the only person who is writing the code, and also you are not the permanent resource in that company. So when it's very obvious, and the software industry is very, I would say, less retaining industry in terms of employee. So employee retention is very low. I mean, usually employee gets switched to new company within 3-4 years. So one responsibility is you have to write something or you have to follow some pattern so that when you leave the company, someone will come into your place and easily they can understand what you are going to do or what you have done already, and from there he can start. So this is a very basic thing you need to keep in mind, that the code maintainability, I would say, or this code readability is very important. You can, for example, you can write a same code when you are alone in your college. You can write it on your language and your methodology, and obviously this is going to give output. But the same thing when you are in industry, you have to write in such a way that it not only gives output, but also it is understandable, readable, and maintainable. So in that way, this design pattern and design principles, which are very important, and our principal madam also, I think, has mentioned that way, that it is very relevant in this current scenario of remote working also. For example, I am not sitting with my colleagues just beside in my office. So I am working remotely and I have to understand what he or she is trying to do. So in that way, this is also important. So, okay. So now I'm going to just show some picture. If you see, these are very funny picture, but yeah. So you see there are some basic faults in design. So you see this brain system is developed, but it is developed in such a way that it is no use. It is of no use. And also you see there is a balcony that is developed correctly, but there is a balcony which don't have any door. So it's of no use. So these are very basic design faults in I would say in the civil or in civil field. But when you are in computer engineering field, there could be some very similar design fault, that you have written a good piece of code which can produce a perfect output, but even after then it is a useless code, and we have to scrap it. So it happens. It happens often when we don't follow some very basic design patterns and very basic design principles. So now this is a very I would say, yeah, it can be recovered very easily. But if you see the next picture, for example, this one, it's a massive one, and yeah, it's I would say it's a disaster. So when it's this kind of disaster, it's very heavy, and even it could just close the whole company who was dealing with this project. So that's why when we are going to start a work, we have to think about the design of and the architecture way before we are going to start the actual development. And also when we are also working, we need to also think about some basic practice. We need to follow some basic practice when we are on the work. So from that way, I would say this design pattern and design principle is very important topic. Now I'm going to, so I will go through some design principle, and then I will go through some design patterns. So what is design principle? I mean, this is a, okay. So this is a, I will go through the solid principle first. So solid stands for single responsibility, then O for open close, then L for list of substitution, then I for interface segregation, and then D for dependency inversion. So when you are going to start the work in your industry, you will very often you will hear this term like solid principle, and you may also face this term in the interviews and all. So what it says, very basic 5 principle that you should follow in your throughout in your career, I would say. So regardless of the technology, for example, you are working in Java, you are working C#, you are working in Angular, whatever the technology is. So these principles are, I mean, you can follow in throughout your career, regardless of the technology. And also there are a few design patterns I will go through, but actually there are 23 design patterns in 3 groups. It was written by 4 people, so that's why it's also known as Gang of 4. And actually there are 23, but I may cover few of them, not all of them. Yeah, but obviously there is a provision that if you are interested, you can go through all of them. Okay, so first I would like to ask you if this is readable or not. These codes are readable? Okay. So first,
Yes.
what is? Okay, thank you. So what is a single responsibility principle? So first of all, when we are in your college, when you are given a particular piece of assignment or particular piece of or some task to write a code, you are writing in your paper or in your computer, and you can write everything in a single class. So that's fine. I mean, that will give you the exact output, but that will violate the single responsibility principle. So what it says a class or a block of code, what you're writing, it should always be responsible for a single thing. Single thing in the sense, for example, a single motivation or a single goal. For example, if you see the first example, so I will go through some kind of piece, the code snippets. And yeah, for example, here I have a user, and then the user is going to create a post. For example, this is an code block of a social media kind of application. Now the user is responsible to create a post. So I have created a class like user, and then there is a method like create post. So what it does, it actually creates, adds the whatever the post message is, it's going to add this message into database. That's fine. And then, for example, there is some exception. Obviously, we need to handle. and then that exception is handled in this catch block. You see, sorry. And here what we are doing, the requirement is you need to log your error into database, and also you need to log your error into a file system. So that's fine. So in this catch block, what we are doing, we are writing that exception into database, and we are writing the exception into the file system. But this is a bad example of single responsibility, and this is actually violating the principle of single responsibility. Why? Because if you see closely, this create post is responsible to create the post. That's fine. The method name is very significant and correct. But this method is not responsible to write the log into the database, right? So for example, I have another post, another class or another method like read post. So that read post should be only responsible to read the post, not responsible to write the log or whatever the thing. So this is actually violating the single responsibility. How we can fix it? So what we can do, we can create a class like post. This post class will have a method like create post. And also the similar thing, it is going to add that message into the database. That's fine. And when some exception occurs, what it will do, it will just call a error logger.log. Now, what is error logger? I have another class that is responsible only for writing the log in the database or file system, whatever. But that is responsible to write a log. So it's not my responsibility, or it's not the responsibility of this post class. So this post class is going to write the post into the database, and that's all. So that's the single responsibility. And also this error logger class is responsible to write the log in the database, not to write the post in the database. So in that way, so this post class and this error logger class are perfectly fine with their own single responsibility. So I hope, I hope this is clear. I can go to the next slide. Now, what is open close principle? So I will extend the same example from previous so that it is relevant and you can relate with the same code. Now, what open close principle says? It says a class, what you are writing should be open for extension, but closed for modification. What it means that you should not touch a class until and unless it is very needed. And you should write a class in such a way that it can be expanded or extended in terms of object-oriented programming. I would say it should be inherited in further subclass or whenever it is needed. So in that way, it should be open for extension and closed for modification. Now come to this example. So I have a class of post, a very similar class like the previous one. Then I have a method like create post. So what it is doing, now you see I have a requirement of a hashtag post. So I think in nowadays with social media thing, you are familiar with what is hashtag. So for example, if there is if you are writing something starts with hash, so obviously it is going to be a hashtag instead of a normal post. So the requirement is if the post message is going to start with hash, I need to add this message as a tag message. Otherwise, it is going to be a simple message. For example, in future, if, for example, the post is going to start with @ and then you are going to tag some of your friends or something like that. So the idea here is you need to parse this message. And based on that, you are going to add this message as a tag message, or you are going to add as a simple message. Now, at the very first look, this is fine to you, I guess, because earlier in this one, it was like only a post message. Now your manager comes to you and says you that, yeah, post message is fine, but I want to implement a hashtag message. So what you have done, you have just added a if else condition that if it starts with hash, I am going to do this. If it is not, I am going to do this. it will give you the perfect output, but you are violating this close principle because you are going to modify a class that is post message, which should not be responsible to post a hashtag message. So what can be done here? You can keep this post class as it is with the create post, and you can create a tag post inherited from post, because a tag post is going to be a post but with some special responsibility or with some special handling, I would say. So in that case, you are going to create a tag post class, and you are going to just add this post as a tag post or something like that. And in future, if something comes, you don't know right now what is going to come. So in future, if something comes, so you can handle or extend your post class as it. I mean, how it is needed in future. So this is and also you see that it actually covers the open principle that this class post is going to be extended in tag post, and also this class post is closed for modification. So this is another very basic principle. But the question comes, may arise like, don't we? Shouldn't we touch this post class at all? No, that's not right. Obviously, if there is something missing or there is something needed in this method or in this class, obviously you have to touch. In software engineering, nothing is I would say bug free in our software terms. So yeah, bugs can obviously appear, and in that case you should touch your actual implementation. But when it differs with your previous requirement, obviously you can go with an extension and inheritance. Okay, so I'm going to the next principle. That is Liskov substitution principle. So what it says, what it means like you have a base class and you have, for example, two subclasses. Now this principle says that your two subclasses should be interchangeable or substitutable. So what it means that your subclasses should not be something like that. They are not related at all, or they can't be replaced at all. And here actually I could have taken an example of that social media thing, but it was a bit complex to understand. So I'm going with a very simple example. For example, I have a class bird. The bird obviously can see, and the bird obviously can fly, for example. Now, at the time of when you are writing this code, you have a class like duck, which extends these birds. That's fine, because duck obviously can see and duck obviously can fly. That's fine. But you are also at some certain point of time that you have to write a class for ostrich, for example. And you see that ostrich is a bird, that's fine, which can see, but it violates that ostrich can't fly. But sorry, can you mute? Arup sir, can you please mute the audio? Yeah, thank you. So obviously, if you see closely these classes, like a duck, it can extend a bird. That's fine because it can see, and it can also extend because it can fly. So that's fine. But in case of ostrich, it can't fly, and in that case, these two are violating this substitution principle. So how we can solve it? We can solve it like we can write a class bird that can see, and then we can extend this bird class into a flying birds class, having another method like fly. Now what happens? Now this ostrich can extend bird that can see, and duck can extend flying birds that can fly, as well as it will have a method of see through this inheritance. So now the siblings here are ostrich and flying bird, and they are replaceable because they both can see.
and duck is actually a subclass of flying birds. So the principle here is you should write when you are writing a base class, you need to keep in mind that the subclasses should fulfill all the things you are writing in your base class. Otherwise, you just break the base class into multiple base classes. So that's the principle. Okay, next is the interface segregation principle. So what it means. So you see, again, I'm back to this social media programming. And here I have one interface like I post. And then I have a method like create post. And then I have a requirement of reading the post. So for example, I was responsible to create the post. So I have created an interface and written my own code. Now my colleague comes into the place and he or she needs to write another functionality, that is read post. So what he or she does is actually she created another interface with both the method like create post and read post. So this is a very bad example of interface segregation. So what we can do, we should do here to segregate both these two interfaces. So what we are doing, we are creating an I post create, that is one interface to responsible the create post, and an interface like I post read, which is responsible to reading of that post. And when my colleague needs to read and write both the post, he or she can easily extend both of these two in his or her classes or interface, whatever. So this is the principle, like we should not leave something like create post in both the interface when they are supposed to do the same thing. So, sometimes it happens that when someone is writing some code you are not aware of, and when you are writing some code that he or she is not aware of, it happens very frequently. So, and also when we are reviewing the code and refactoring the code at later point of time, then these things comes into picture, and then we can segregate some of the interface into one, or some of the interface break some of the interface into two. So all this principle and the previous this substitution principle comes into place. And these terms, could be at the very first like very theoretical in terms of these terms and theories and all, but you will get habituated with these things. And then these things will not be in theory, but in your practical everyday work. And then there is another, the last, I think, is the dependency inversion principle. And I think you have already gone through some of the things like dependency injection and all in your already, syllabus, I think. But what it says, dependency inversion principle, is, if you see, again, I have this with the same class post. And if you remember, I had one logger and I was creating the post. That's fine with a single responsibility. It is adding the post into the database. And also using this logger, it is going to write the log into the database. But I am violating again another principle, that is dependency inversion. So what it means? It means, you see, this post class is actually creating one instance of logger. That is not his responsibility. That is not the responsibility of post class. So what we can do, for example, we are injecting this DB reference or the post message. Same thing we can do when we are creating the instance of post in the constructor. We can inject this logger. So the logger, this post class should not be responsible to create a logger instance. He is only responsible to create a post, and then this logger instance or reference should be injected from outside, from the caller class who is calling this post message. So from there, this can be injected. So this is kind of a constructor injection, I would say. And you will find based on this principle, there are so many platforms are dependent. For example, very popular example is AngularJS and Angular. So yeah, so this is a very common principle where you should not write everything in a class when he or she is, this class is not, should not do that. So you should inject that particular outside thing, I would say, into that class through constructor or whatever. Okay, so I think I have covered the design principle, solid principle, like all these 5. And I would request you just go through in the internet and all, and you will get some more and more idea. These are very basic principle and in theory, but in practice, these are very basic things. Now, I will go with some design patterns. Like I mentioned, like there are 23 design patterns in 3 groups, and it's obviously not possible to go through all the patterns in this given time frame or limited time frame. So I have just chosen few of them. Sorry, I have chosen few of them and chosen in such a way that they are the most used in industry, and you will get to see them very frequently. Sorry. So first thing is the creational design pattern. So, sorry, give me a minute. So now, first thing is we have divided the design patterns into 3. First of all, this is creational, this is behavioral, and this is structural. So creational is how you are going to create your objects in your programming. So when you are writing a program in your college assignments, maybe there are 1, 2, 3, 4 type of objects. But when you are actually dealing with the softwares in industry, there could be hundreds and thousands of objects. And also there can be various kind of inheritance, various kind of base class, interface, and so on. So you have, and when you are going to work in some existing project, and then it will get more complex. Like there are thousands of objects and how they are getting created, where I should create. Because for example, when you are writing your assignments, you need an object, and you can easily create object A equal to new object or something like that, wherever and whenever you want. But here when we are writing the actual software, we cannot do. We cannot do in the sense, we should not do actually, because this creation should have a structure. Or you can think about the first thing is the factory is a very common term. So we should have a kind of factory from where I will get the instance of object. Or if I want, for example, a very single instance of an object, we can go for a singleton pattern. So these things defines the creational design patterns, like how and where I should create the objects. And then there is behavioral design patterns. So what it means like how our block of code or the structure should behave. Yeah, you can change the behavior of a code, or I would not say change, but you can define the behavior of your coding structure. So that covers the behavioral design pattern. And there are few. So I will go through some very basic thing like command and iterator. And then the last one is the structural design pattern. And here you would see some kind of example of how you can structure your program. So when there is a question of multiple classes, thousands of objects, and multiple kind of behaviors, and then in that standing on that platform, how you can structurize your code so that it is easily understandable, easily maintainable, and all. Okay, so I will go through all these 6 patterns one by one. Let's start with singleton. So what is singleton? I think you are already aware of static classes. Like when you need a single instance of an of a class in throughout your programming, you obviously go with the static, right? This is the very I mean, yeah, this is very common. You know that static is going to have only one instance, but static is not useful in all the cases. For example, you are writing a multi-threaded programming, and obviously when you are writing a big piece of software, I mean, it obviously is a multi-threaded or somewhere some thread and yeah, tasks are running and so on. So in that scenario, static is not a safe option for you because static is not thread safe. So what will happen? You are going to you have written some resource or you have kept some resource into static class, and from various block, various piece of code is trying to access that particular resource at the very same time. So it will throw you exception and it will fail actually. So what is the solution? From there, the solution is a singleton class. So singleton class is just as a normal class, I mean, the simple class which can have instance, but it is designed in such a manner that it is thread safe and all. And also static can't have a instance like, but singleton can have. So now if I go through this example, I have a logger class. You see, this is a normal class, not static. And then I have a private constructor. So this is the most important thing. So I have a normal class with a private constructor. That means from outside, it is not possible to create the instance of this class. So who can create this class, instance of this class or call this constructor? This class itself can call this constructor. No one else can call. So how the obvious question, how we are going to use this? If the instantiation is not possible, this is not static, then how we can use it? So then we can have a static method out here. So what it does, I have just named it like instance. So what it does, this static method is going to return the reference of this class instance, that is logger. And then what it is doing, I am checking. And also you see, I have two members out here, private members. I mean, this is public. Yeah. So first is the reference of this class itself. And second one is a lock. So why this lock? This lock is going to be used to restrict multiple threads. Now what we are doing here in this instance, you see, first I'm checking at the very first time if the logger, I mean this member variable is null or not. If it is null, that means it's very first time. I am locking this code. I mean multiple thread can't enter here at the very same time. And what I'm doing, I'm just creating a new instance of logger. This logger is nothing but this constructor. I'm calling this constructor out here. So I'm creating a very new instance of this logger, assigning it in this variable, and then I'm returning it. Now, the second time when the calls comes in, it will check if the logger is null. Obviously, it is not null. So then it will not enter in all these things. It will just return this one. So obviously, in such a way, I have written this code that every time it will return only, it will create the logger. First of all, it will create the logger instance only once. So it will create this logger instance only once. And next time and so on, it will return the last instance which was created the first time. So in this way, we can manage a class that it will have a single instance throughout its life cycle of the application. I mean, till the application is running. So this is how the singleton works. Now you can see a very simple example of this class. So this is the use of this class. For example, let's say logger was not for example, what I would say, logger was not a singleton class. So what we could do. Sorry, this okay. So what we are doing out here. So we are creating a logger1 equal to logger.instance. That means we are calling this one. Obviously, I'm getting an instance, reference of this logger class, and I'm writing this log message1. Second time, I'm doing the same thing. I'm getting the instance of this logger class, but this is not going to create another instance. It is going to return the old one. And also I'm writing another message. But instead of these two, what we can do, we can easily write like this, a code like logger.instance.log. This will do the same thing. This will do the same thing. So the point here is we don't need to create a reference of this like logger2, logger1, because they are same actually. They are going to be the same instance of this logger class and the single instance. And that's why it is known as the singleton. Okay, so I'm going to the next slide, that is factory. So I'm going to the next slide, that is a factory pattern. So in principle, in theory, there is actually abstract factory, and also there is a factory called a factory method by which you can create your objects. But they are a little bit detailed, I would say. But so I just created one simpler example of factory so that you can understand what factory is. So by its name, you I think realize that a factory is something that produces some product, for example. And similar in the software, this term has been taken, like a factory is responsible to create the instance of some classes. And if you go through this consumer of product, and then I have some product interface so that this client can, factory can understand what I need to produce. So obviously this interface is a vital thing to, because the client can ask something else to the factory which factory can't recognize. So obviously there will be some recognizable product that will be produced by the factory and consumed by the client. Okay, now how it is written, a very basic example of factory. Again, this is not the very good example, I would say, for factory, abstract factory or factory method, but it is you can get an idea of what factory is. Okay, for example, okay, so for example, I have one product that is, I have one, like I said, I have to make this client and factory understand that what it is. So I have one interface of product, and then I have two products inheriting from this I product. That is, this factory can produce multiple kind of product, but there is a similarity between them. So that's why this is, for example, one product that implements this interface, and there is another product that implements the same interface. Now, in your system, you have two products, you see, but they are somehow related in a way like they are inherited from the same interface. So at this point, what's the requirement is, you can write your own class, or you can write your own client class, and you can create whatever the product you have, just creating the one product equal to new one product, or another product equal to new another product. This is very simple. You can do it in your client class. But again, you see, it is violating the single responsibility principle, if you remember. Like, your client class should not be responsible to create or to handle this logic when I need to create one product, or when I need to create another product. This client should not bother about that. So what we can do, we can have a factory class like product factory. And then what we are doing out here, for example, again, you see, I just made it like a singleton for ease of use. I have a private constructor of this factory, and then this is instance, that's fine. So now this is the actual factory method. Where we are actually handling the creation of this project, of this product. So this method is going to take the ID of the product, and here I'm checking if ID is 1, then return the one product. If ID is 2, then return the another product. Very simple, because the factory knows this. So what it means that this factory knows and understand and has the knowledge that when I should return one product or when I should return another product. Now, how we are going to use this factory? For example, this is the client or the consumer, you can assume. So what we are doing, I have a reference of this interface, this one, and then we are doing like product factory dot instance, because this is a singleton, and then I'm doing a create product, and then I'm passing the ID of the product. Again, in the next line, I'm doing product 2 equal to factory dot instance dot create product, and I'm passing the ID 2. Now it's the ability to return whether one product or another product. And you see these this factory test or main or this client don't have any, doesn't have any responsibility to create the product. So this is where, this is how the factory comes into picture. And again, this is not a very good example, I would say. There are some SQL Server and Oracle. Thing you should write sometimes in SQL and sometimes in Oracle based on your configuration. You know that in your application you can have a configuration file that can be modified after even after your product is already installed in the system without touching the code. So for example, something I have written in the configuration that this product should write everything in the SQL Server, or the either way, this product should write everything in Oracle. And this situation can be handled by this factory. How? That you should read the configuration in your program that, okay, I need to get an instance of Oracle, the reference of Oracle or SQL, and the factory should return you the exact instance of that particular connection. So this is a very simple example and what we very often use in the programming. So these were the two very basic things like singleton and factory. There are object pools and other patterns that you can go through. Now I can go through some behavioral patterns like command. So what command is in a very casual note, I would say, when you so command is if you think in a real life, like command is something that tells you to do something, but the actual implementation or the actual task is not mentioned in that command, or it's hidden inside that that thing. So you can think about in that direction. Like, for example, I have one document, and you know that a document can be opened and document can be saved. There are very, system IO, I would say, libraries in Java, in C# and everywhere to open a document and close document or save something like that. Now, the requirement is, for example, there is a menu in your UI that you will click something that it will open the document, and you will click another menu, it will save the document. That's fine. You can call this directly. But another possibility is you can write a command like you can write a command like this. This is action listener command, which is having one, this is interface actually, and you are having one method that is execute. So you are going to have one command, and there you are going to have one execute method. Now what you are doing, you have an implementation of this interface where you are actually having this action open. I mean, the class name is action open, for example. What it is doing, it is getting the reference of the of that document, and when you are calling the execute, it is actually opening that document. So the class is action open, and when you are calling the execute, it is going to open the document. It is relevant. And for example, you have another one like action save implements action listener command, and in the execute you are going to call this block of code. So the point here is this class, this action open, is actually following a command, that is action listener command, having a method execute. So when you are, so this okay, now go in the actual calling of this method. That will be easier to show you. So I have like I mentioned, like you can visualize one UI that you have two menus. One is to open the document, another one is to save the document. Now, for example, in this one, in the menu system, what you are doing, you are passing one command for open and one command for save. At this point, you are just you are just storing your command in your in this menu option class, and when something is clicked, like open is clicked, you are just executing this command. And here, when save is clicked, you are just executing this command. So the point here, you don't know the actual implemented. So another way you could do is, you have this document, you can easily open this document out here itself. But again, you see, this is a menu option class. This is not a class to deal with the documents. So what you can do, you are executing a command to open the document, you are executing a command to save a document, but you are not doing the actual task out here. The actual task is going to be done out here, but through a command. So this open command and save command, you see, this is the same reference, action listener command, which is the interface. This is action listener command, which is this same interface. So this is the idea here is to wrap the actual or hide the actual implementation from the caller by some interface or by some command pattern. So this is also very useful or very much used pattern in softwares you will find when you are going to start writing your code in industry, that you will find something like a very similar example. That may not interpret with exactly command, something else, but it will follow these kind of patterns. Now there is another example of iterator. So what is the iterator pattern? For example, you know that you have a list of object, for example, or an array of object, and obviously you can just loop through it to traverse that list or the array. And this is inbuilt in all the programming language, like starting from C# or Java or C++. Everywhere you have this iterator over the list and array. But for example, you have your own object, and here the example is with a remote control. So you have, for example, 5 channels. So obviously channel is going to be a class, and you want to iterate through this channel without, for example, having the list and so on. So you are going to build your custom iterator on that object. So what I have one iterator interface again. I have a channel, like I said, channel, for example, is your class. And then I have 2 channels. Two methods. One is the next channel, another one is the previous channel. So what is going to return, if you input the current channel, it will go to the next channel. If you input the current channel, it will go to the previous channel out here. Now I have, this is the actual iterator where I am implementing this iterator class. This is the channel server. Now what we are doing, we are on when we are calling the next channel, we are creating a channel instance of current channel plus one, and we are returning the that channel. And when it is a task of previous channel, what we are doing, we are creating a channel with index of current channel -1, and then we are returning. The idea here is whatever is your what you could do in a list or array, that logic we are implementing on our own. For example, in next channel, if it is a list, for example, you are going to get when you are traversing, you are going to get next, next, and next. But here in this next channel, you could implement the current channel +1 or +2 or something your own on your own. Your own implementation can be done out here. So so here this channel server is an iterator which you are going to implement. How you are going to get the next object or the previous object, you are going to decide, not the inbuilt library list or iterator or whatever. So this is the idea. Like when you are going to implement or when you are going to see similar kind of requirement where the existing list and array is not very much fitting with the idea, you can go with your custom iterator. Next is the adapter. I think you have seen at the very first of slide, I just shown one bridge. I mean, the two portion of the bridge that were not matching exactly. So one, for example, one team was building the one part and the other team was building the remaining part, and they are not matching. So it happens very much in our programming language. So when it's a single team, yes, you can refactor your code and you can adjust your code in such a way that they are going to match exactly. The two block of code can talk to each other how they are supposed to. But for example, you are working with a software and that's a product of your company, and then again you are going to talk to another software product that is developed by another company, then you don't have that flexibility of modification, or what I will say, the adjustment, right? So in this kind of scenario, we can have some adapter. The name suggests like something in between that will fit either, both side of the world. So now, for example, I have just taken a very simple example. Like I have a number sorter class, which can sort actually a list of integer, for example, very simple thing. So this number sorter class having a sort method, which can take an input of this list of numbers, and which is going to return the list of integer. The sorted list of integer. This is very simple. But here you have a requirement. This is another. Okay, so now, okay, so for example, this is written by a third-party company, or some portion of your company that you don't have any control. So every time you are going to call this number sorter, you have to send a list of integer. But you don't have, for example, you don't have, when you are writing your piece of code, you don't have that list of integer. You have an array of integer. So what you can do? I know that these modern codes and all is having in build library like that can convert array to integer. But this is an example. For example, you can't, this kind of an object that you cannot convert from, for example, array to integer. So it's not your responsibility. But you have an array that is pointed out here, array of integer, and you want to sort this array of integer, but you want this third-party sorter. So what you can do? You can have one interface like this sorter, which is having this, which takes an array and returns an array. That's fine. Now, this is where you are writing your adapter. So what adapter is doing? Adapter is taking one array of numbers, also will return array of numbers, but internally what it is doing, it is calling this class, this number sorter class, and actually doing the thing it is supposed to do. It is calling the sort method, and then it is actually converting this array, I mean the list, sorted list to array, and returns this array. So this is your piece of code where you are having an array of these numbers. You are calling this adapter. You don't know this one, and you don't have to know actually. You just understand this adapter. You are calling this adapter, and then you are just calling the sort method of this adapter, not this one. Now this adapter is going to do the magic, like it will convert the list to array or array to list, whatever. I mean, this is a, I mean, again, I said that this may not be very actual example, but there can be some objects which are related but not exactly convertible. If they are in a same company, then we can have, for example, an interface written out here, and then we can have some conversion and so on, but it is not obviously always possible. In that case, we can have an explicit adapter. And again, you can ask, or you can have a question like, why can't we write this piece of code here? Yes, you could write this particular piece of code in your code where you are writing the code. But the problem is, for example, your colleague next day is going to have or is having a requirement of using the same method, and then he is going to write this same thing again in his code. So this is the bad thing. And for example, there is something change in this logic, so you have to change here, you have to change here, and wherever you are going to use this thing, you have to change everywhere, and there is a possibility of introducing the bug. Because you are changing out here, but you forgot to change this one out here. So in that case, this adapter is going to be a very generic thing, where, and also is going to be a single place of adapting the third party or this thing, and then you can use it everywhere you just want to use that through this adapter. Okay, so next thing is the proxy. So this is the last pattern, I would say, in this structural design pattern. Now, what is proxy? Again, proxy is very used in the situation, like I said, in this adapter, like in a scenario where you are going to adapt something from third party or something from a different team. You are going to so in that case, in adapter, you were the consumer of some third party thing. And in case of proxy, you can think about, you are the developer of some module or so on, and you are going to give your client or your consumer a lightweight version or lightweight interface to adapt your functionality. For example, in previous example, you have written that sorter class, and you want me to give the interface of that. So in that case, you can share a proxy of this thing. So what is proxy? I have one image class, for example, out here, that can display this is an interface like image, and that can display the image, whatever is given, for example. And then I have one real image class that implements this image interface, and I'm passing the URL to this one, and I am loading the image. So you can think about, like, loading the image is a big piece of task. For example, if it is it's a high resolution image of, for example, 24 to 30 megabyte, and it's a piece of resource consuming task. For for example. So that's why we just mentioned like this is a real image where we are actually loading this image. That's fine. And then we have a display method that can, after loading this image, that can display this image. So again, you are the developer of this part. You are not the consumer. Now to the consumer, what you can expose, you could expose like the real image class to them, and they can call this real image and use those things and load method in their module or whatever. But instead of doing that, you want to share a lightweight version of this of your implementation. What is that? You are going to share an class like proxy image. So this is a lightweight version of your real image. So what it is doing, it is implementing the image interface because this client wants to display or wants to show the image. That's fine. This is the final goal. But this is going to be a proxy image class which is having the image URL you are passing and which is having a display method. And in this display method, you are calling the actual image. I mean, this is the real image, and you are having this real image dot display out here, which is doing the actual task or resource heavy task. Now, if you are going to share this proxy image to your client, then they don't know what the real image is doing internally. So they are going to have a lightweight version of real image to their module or so on, and they are just they are aware of that thing only, not the actual implementation. So, and this is a proxy. You will be having, for example, you are building and this is a very familiar term in web service. For example, you are going to develop a web service like SOAP web service or REST or whatever. And then obviously you are going to share the proxy references to your clients or to your consumers, not the actual implementation of your code. So in that way, proxy is a very generic term and is a very well-known term in your, so is going to be a very daily basis used term kind of thing in your daily life. So whenever you see a proxy, you can think about this is the interface or this is the interactive point. I mean, the point where you can interact with a third party or a module which is developed by some other people, but you don't know the actual implementation. You have the proxy, and you blindly have to use their proxy classes and proxy interfaces to call their method. But the actual things or actual work will be done in their module. So this is another way of representing or another way of communication between two different teams, two different companies, two different modules. Okay, so I think I have covered all these 6 patterns, and there were 5 design principles. And again, so don't take all these things as a theoretical point of view. You will get and you will be habituated with all this practice and these things on your real life day-to-day work. I mean that may not be termed as this kind of pattern or that kind of pattern, but yes, they exist. And if you're aware and if you are if you know these things, these are good in your career. And if you can follow especially those very basic principles, that will give you a mileage in your career, obviously. And that's all. And I think I can hand over to Arup, sir.
Thank you, sir. It is you enlighten us so nicely and give some examples and share with your experience regarding that particular domain. And can I start one interactive sessions regarding this webinar, sir?
Yeah, sure.
So I request to all the participants, if anyone have any queries regarding the today's webinar from this topic, you can write through chat box. Then after one by one, Sir will be discuss it. Okay. So now, anyone have any queries regarding that OPPs, which already Sir discussed through the presentations? So you can write through chat box. Anyone have any queries or any doubt? Any participants? So, sir, one question from Biplab Rudro. How we can cope up as soon as we enter the industry? Sir?
Yeah, thank you. I think the question is from Ovik, right?
No, Biplab Rudro, first question is how we can cope up as soon as we enter the industry. That's
Okay.
how we finish the industry. That is.
Yeah. Thank you, Viplab, for your question. But the thing is, you don't have to worry about how you are going to be fit in the industry, because it's the company's responsibility to fit you in your job, because it's their interest. Yes, obviously, it's your interest and it's the company's interest to fit you in the correct role. And then when these patterns, these basic principles, these best practice you are following, you are going to sign. Yeah, for example, there are 5 fresher, or there are 5 new joiner in a company. All 5 are writing a same piece of code or same kind of functionality, but that is going to give the same output. That's fine. But when you are writing something which is nicer, which looks cleaner, which looks nicer, which follows some basic principle, that's the thing. What is noticeable? I mean, what is going to give you the extra bit of mileage, rather? I mean, which will keep you ahead of the others.
So I hope so. Biplab understands. Sir give us nice explanations. The next question from Obik Roy. Sir, how the solid principle is followed in industry?
Yeah. So, like I mentioned multiple times, like these terms are may not be used as a theoretical thing every time. Like when you are writing, when you are given a task at the very beginning of task, like in your college assignment, you are not going to write that this is going to be a single responsibility principle in top of your class. No, it's not like that. But in your daily life, in your day-to-day coding experience, you will find that these things are followed. I mean, these things are practiced and followed regularly in your regular basis without these terminologies. For example, never you are going to, when you are going to write an actual software, you are never going to write something that, for example, 10 different piece of functionality or 10 different piece of features in a single class. That's a very bad practice. So in that way, they are followed in industry, not like the college assignments and all, where you are theoretically mentioning that what I am supposed to do and what I am going to do. No, it's not mentioned explicitly, but yes, it's there.
So another question asking the Tanmoy Chatterjee. There is any implementations OPP design methodology? Can you discuss those aspects? That is OPP design methodology.
Okay, so if I get you correctly, Tanmoy, like I just gave an example of what was the question of Ovik, like design principle, solid principle. Your question is how the OPP design pattern. For example, I have given a very simple example of factory, right? You can have one product that is going to write, for example, a product that is developed by, for example, Wipro, let's say, a software company, and that product is going to be used by two different banks, let's say State Bank and let's say Axis Bank. But the State Bank is having the license of Oracle, not the SQL Server, but this Axis Bank is having the license of SQL Server, not the Oracle. But the Wipro is going to produce, or the software company is going to produce a software that is capable. I mean, they are going to develop, they're not going to develop the software multiple times or the product multiple times. They are going to develop the product one time that will fit both for this bank. Now, what they can do, they can have a configuration or a config file which is having this connection. That connection can be a Oracle connection, connection can be a SQL connection, that can be a MySQL connection, or whatever the database is. And then they will deploy, when they will deploy that particular software in a State Bank environment, then they will configure that thing with Oracle, and then for the other, they will configure with the SQL Server. And in their actual code, what they will use a factory to detect or to produce the actual connection object, I mean the connection object of that particular type. So that particular software is going to fit with both kind of thing having a factory internally. So this can be one example.
Thank you, sir. So I think another question is coming from Riya Chakraborty. So it is important to follow and learn all 23 patterns, or the 6 patterns that you mentioned are enough important.
Actually, yeah, like I said, I have yes. So I have purposefully chosen these 6 because I feel in my way of career that I feel that these things are very common, and I have seen these things multiple times in daily to daily basis in multiple clients I have worked with, multiple technologies I have worked with. So these are very basics, these 6 patterns and so on. So yeah, obviously if you have if you want to learn, obviously these 23 patterns are going to help you. But yeah, at the very first, they may be overwhelming for you. So you can start with very basic things, and then you can obviously, when you progress, you can learn. So there is no harm on learning.
Okay. So thank you, sir. So nicely you explained the different patterns. So any more questions from anyone? So now, so no questions. Any more questions from anyone? So participants? No. Gopal sir? You? Hello, Gopal sir? Hello, Indra sir, you can share the screen, okay?
Yes. Okay.
Okay. So so this is more token for you, sir, from the behalf of RERF Group of Institutions, the Department of Computer Science. I invite you on these occasions, and you give us that opportunity, and you share your real life experience in the industry. That is, in lively we get some information from the working in industry. All the participants also learn something from your sessions. So nicely you explain this today's webinar. So it is great pleasure to all of us that you gave this opportunity to us. And due to this world pandemic, we are here with this virtual platform. It is a privilege for us if you come in our campus, that means our institutions in Barakpur. It is a great pleasure for all of us. So after this pandemic situations overcome, we all, on behalf of RF institutions, gladly waiting for you, sir. Please come in our campus